Okay, so experiment number 1, live recording notes, optimization. A farmer wants to construct a rectangular pig pen. So we have a rectangle, 300 feet of fencing. The pig pen will be built next to an existing wall. So it's a 3-sided fence basically that you're building. And you will recognize this problem from Algebra 2 when you did parabolas. Only in Algebra 2, you just found the max or min using the vertex. We're going to find it with a derivative. So this is kind of like the baby intro. So you make a little picture of the situation. Put an x and a y. It doesn't matter if that's your variables used. Usually I try to be consistent about it. And we want to write a formula for what we know. So the fixed item here is the amount of fencing. This is like yesterday with your paper. The fixed was the piece of paper. So the amount of fencing here, 2x plus y equals 300. And the reason we do that is we want to get everything in terms of x, because we don't want to do related rates. We don't want to do two variables. So y equals 300 minus 2x. So that you can rewrite this side as 300 minus 2x. Okay. So it says the pen will be built next to the stone wall, blah, blah, blah. What dimensions should the farmer use to construct the pen with the largest possible area? Largest meaning maximum. Okay, and a lot of these won't have a max and a min initially. So really, we're going to find where the derivative is 0 and we'll be done. Okay, so the largest area. Well, area equals x times y. So in our case, the y is the 300 minus 2x. Some of these are really nice. Like this is going to be a really easy derivative. Some of them we'll solve with our calculator. So area equals 300x minus 2x squared. To find the max or min, that's what optimization is. We set the derivative equal to 0. So to take the derivative, 300 minus 4x, set that equal to 0. 4x equals 300. 300 divided by 4 is 75. So you always go back and answer the question, what dimensions should the farmer use? And you need to be specific as to where the 75 goes. So 75, 75, and then this is 300 minus 2 times 75, so this is 150. So 75 by 150 would give you the maximum area for those fencings. Now, one way you can do this problem also would be to say, well, if we have 300 feet of fencing, try figuring out dimensions that would work and just guess and check. So if one side was 100, then the other two sides would be 100. You could find that area. If one side was, it could be ridiculous on the other end. If this side was 10, so we'd have 10 and 10, that's 20. That would be 10 by 280. You can always just multiply them together until you get there. There definitely will be a pattern with some of these with the rectangles.